Welcome back, everyone. So now it's time for us to conduct the publication workshop, which is organized in line with ICUHT 2020. So for many of the conferences that we organize, we incorporate a workshop which discusses about publication prospects and also the methodologies, and also with supportive workshops to authors to develop their papers in future. So this time we have focused on quantitative methods in research. So this workshop is titled as When, Why, and How Can We Apply Partial Least Squares Structural Equation Modeling in Academic Research. This particular workshop will be conducted by Dr. Mostafa Rasoolimanesh from School of Hospitality, Tourism and Events, Taylor's University, Malaysia. So before handing over this session to Dr. Mostafa, I would like to give a little introduction about Dr. Mostafa to you all. Dr. Mostafa Rasoolimanesh is an associate professor at the School of Hospitality, Tourism and Events of Taylor's University, Malaysia. And his research interest areas contain sustainable tourism, heritage tourism, urban sustainability, and advanced quantitative data analysis such as partial least squares structural equation modeling. He has published widely in high-impact journals such as Tourism Management, Journal of Travel Research, Journal of Sustainable Tourism, Journal of Cleaner Production, International Journal of Tourism Research, and International Journal of Contemporary Hospitality Management, among the many. He has applied PLS-SEM method using different software packages in most of his published papers as well. Dr. Mostafa and his colleagues have published several methodological papers and books and special issue on PLS-SEM, which their paper on PLS-SEM published in International Journal of Contemporary Hospitality Management won the Emerald Literati Award in 2009 as an outstanding paper. Dr. Mostafa serves as an associate editor of Journal of Hospitality and Tourism Management and special issue editor of Journal of Hospitality and Tourism Technology. In addition, he is a member of editorial board of several reputed SSCI journals as well. So Dr. Mostafa, without further ado, I would like to hand over the workshop to you. You may share your screen now and start the workshop. Thank you so much.
Thank you very much for a nice introduction. Hello, everyone. Good afternoon, good evening to all. I'm Dr. Mostafa from School of Hospitality, Tourism and Event. Actually, before going to my slide, I would like to thank the organizer to invite me for this conference and to share about PLS-SEM. Hopefully this workshop, you can get some tips from this workshop and it will be useful for future research and publication. Before going to my slide, actually I want to show you some document and material related to PLS-SEM. So you may find this document useful for your future research. This is a book that we actually published in 2018 by Emerald, Applying Partial Least Squares in Tourism and Hospitality Research. In this book, actually, we have several chapters that some of these chapters have been written by very well-known people in PLS-SEM world. For example, first chapter is about sample size, and this chapter has been written by Professor Ned Koch. And the second one is the guideline for PLS in tourism and travel research. It's written by Prof. Jörg Hensler and his colleague. And also you can see other chapters on prediction and guideline for application of PLS and some empirical chapters. This is the book that actually we focus on application of PLS. This is another spatial issue. Actually, that's this spatial issue we published in 2018 in Journal of Hospitality and Tourism Technology. And in this spatial issue, we've actually published several papers from well-known researcher on application of PLS and some methodological paper about PLS on in hospitality and tourism. So in this spatial issue, that is volume 9, issue 3 of the Journal of Hospitality and Tourism Technology in 2018. So you can go through different papers that publish in this spatial issue, and you can, I'm sure you can get very good insight from this paper in this spatial issue. Also in this spatial issue, we have published a guest editorial, and in this guest editorial, in simple language, we tried to discuss some basic topics and component of PLS-SEM and assessment of measurement model and structural model. In my presentation, actually, I will refer to this guest editorial, and here we you can see comparison between composite-based and common factor-based SEM. In my presentation, I will go through this the definition of these two methods and compare these two methods. So in this editorial, you can see this comparison and also a definition for reflective, formative, and composite construct, and assessment of these three different types of construct that nowadays in social science, we are dealing with these different types of construct, and we need to be aware about type of construct for assessment of our model. Also, in this paper that we published in International Journal of Contemporary Hospitality Management, also some part of my presentation is based on guideline that we provided in this paper. So in this paper, actually this paper won Emerald Literati Award in 2019. And in this paper, actually we provided a clear guideline at the end of this paper for hospitality and tourism researcher, and of course for social science researcher in general, that you can use this guideline. And in this guideline, actually we started from data characteristic and sample size, and we discussed different matters related to research, quantitative research, and the application of PLS-SEM. And we provided some recommendation and rule of thumb for application of PLS for different actually steps of your analysis. So this paper, because of this Emerald Literati Award, is open access for entire year of 2020. So you can go to journal website, International Journal of Contemporary Hospitality Management, and download it. So it's free to download. So this is some actually the material, paper, and book, and especially issue that before starting my presentation regarding PLS, I wanted to show you. But another point before my presentation, I want to highlight that actually my research area is two different folds. One focus on sustainable tourism and heritage tourism, and actually most of my published work in content are related to sustainability and heritage tourism. And actually I enjoy the talk, keynote speech morning, and I actually also attended some presentation. Especially I really enjoyed the discussion and topic presented by Dr. Kong from GSTC related to indicator of sustainability assessment in hotels and their destination. Another area that I'm working actually to enrich our understanding from social science is advanced quantitative data analysis, and PLS is one of them. Recently, I started to work in another approach and mix this approach with PLS. Combine this approach is fuzzy set qualitative comparative analysis, FSQCA. Hopefully, in the future soon, we come out with we publish some paper related to combination of these two methods. And actually, these methodological work on quantitative data analysis can help social science researcher to extract and understand social phenomena, and actually can help us for better understanding of these concepts in the context of social science. Okay, let me go through my presentation. Can you see my presentation, right? My slide.
Yes, Dr. Mostafa, you can see it.
Okay, so the topic of today is today workshop is why, when, and how to apply partial least square structural equation modeling for our academic research and of course publication. Why SEM? Why structural equation modeling? Before going to PLS, I want to highlight some point about the SEM and structural equation modeling, because actually PLS is part of this advanced quantitative analysis technique. Structural equation modeling is called the second generation of data analysis, second generation of quantitative data analysis. Contrary to first generation, in second generation, we actually work with the different types of variables, construct, and very complex model. So this is two main reasons that we need to apply and recommend to apply structural equation modeling. So the first reason is actually the SEM and second generation can work a framework with the different level of complexity and the different layers. If you have a connection between different variables, some antecedent influence on some variable, again, this variable influence on another variable, and you have a few layers in your framework. So you can analyze your whole framework simultaneously, all relationships simultaneously. So this is possible in structural equation modeling. But you are familiar with the first generation. In first generation, only we can deal with the one layer relationship, antecedent on dependent variable. If we have another layer, we need to run more than one time, a few times our framework. So we need to split our model to a few models. When we split our model to few models, it means we skip relationship of an effect of other variables. For example, when we assess relationship between antecedent and dependent variable in first layer, and we have to delete, we have to skip relationship in second layer. So it means this relationship doesn't affect on actually testing hypothesis in first layer. So our result won't be actually accurate result. But in a structural equation modeling, we are able to run whole model in one go. So no need to split our framework to different framework, different models, and different layers. This is one of the main advantage of structural equation. In social science, you know, most of time our framework, our model is complex model. And we have relationship between different construct, different phenomena, different variables. So we need to see the effect of variable in a whole model, in an integrated model. So it's not possible by first generation, but second generation actually make it possible to run our framework in one go, one run, right? This is one and first main difference between SEM and first generation analysis technique. Another very important difference between SEM and the first generation of analysis is second generation or SEM can work with latent variable. What's the meaning of latent variable? In social science, most of time, we work with latent variable. For example, you have a brand image in your framework. You have satisfaction in your framework, loyalty, attitude, behavioral intention, right? You're working with this type of variable. This type of variable called latent variable, because this variable, for this variable, we are not able to measure this variable directly. We don't have any specific or physical scale to measure these variables, to measure satisfaction, to measure attitude. So for this type of variable, we develop questionnaire, we collect data, and for each variable, we adopt some items to measure. For example, for attitude, we use 5 items to measure attitude. For satisfaction, we use 4 items to measure satisfaction. And based on answer of respondents to these questions, to these items, we can measure attitude, we can measure satisfaction or loyalty, right? So we are working with the latent variable in most of studies in social science, and of course in most of studies in hospitality and tourism, right? But what happened in first generation? For example, if we want to assess, we want to measure and assess relationship between satisfaction is in a simple model. Satisfaction and loyalty in tourism studies, satisfaction about destination and loyalty, or satisfaction about hotel and loyalty. In first generation, what we do? In first generation, actually, we need to calculate score of satisfaction or score of loyalty before performing our analysis, right? It means in SPSS, if we use SPSS for our analysis, in SPSS, we need to calculate score of or average of items to measure loyalty and calculate the score of loyalty. So we create a new variable called loyalty, a new variable called satisfaction based on the items of satisfaction, right? We get average of these items. So we use this score for our analysis. Actually, we need to transfer items that called observed variable, the variable that we measure directly, to score of latent variable, and then we are able to use this score for analysis. So first generation actually are not able to work with items, are not able to work with latent variable. We need to convert latent variable to observed variable, but by calculating the average of items for analysis. When we do this one, what happened? We skip error term. We consider all items with same weights. We call all items with same effect to establish latent variable, but actually in the reality is not correct. In the reality, when we have 5 items to measure satisfaction, these 5 items play different role and has different effect to establish satisfaction. But when we get average, means we ignore these differences between items. So this happened in first generation. But in second generation, actually, we are working with latent variable. So we don't need to calculate latent variable score. We can include observed variable in the model, and the observed variable based on different algorithms will calculate based on the weight of each item and the importance of each item and role of each item. Will calculate the based on different algorithm score of latent variable, and this score will be used to assess the relationship between construct or factors or variables, right? So this is second main difference between first generation and second generation. In social science, you know, if I don't say always, sometimes we have some items with some variable only with one item, or some variable that we measure directly, for example, price. If we include price in our framework, so price is a variable only with one item and clear variable. But most of the time, actually, we have some construct and variable that we measure based on some items indirectly. So this is second benefit and advantage of application of SEM compared to first generation. Even when we have a construct only with one item like price, but we include price in a complex framework with different layers. And so SEM is preferred because we can run whole model together and all relationships simultaneously. So we don't need to divide to different models, right? Okay. So this is why that we need to apply SEM. But later I will answer why we need to apply PLS. I will compare PLS and CB-SEM, and I will explain later. But before going through this one, just I want to explain some definition on structural equation modeling. Actually, when we apply SEM, we use some new definitions. For example, we use exogenous variable and endogenous variable or latent variable or construct. We don't use independent and dependent variable because actually we have different layers in the framework that we apply SEM to analyze this framework. So using independent variable and dependent variable is a bit confusing. So we use exogenous and endogenous. Exogenous is similar to dependent variable. Exogenous variable are some variables or construct that there is not any other variable pointing to this variable. So these variables are first layer of our framework. But endogenous variable is somehow similar to dependent variable, but not same. Or some variables, some construct that at least one other construct, one other variable pointed to this variable. So we use this definition instead of independent and dependent variable. Another things that we use in SEM is inner model and outer model, or structural model and measurement model. So inner model and structural model can be used interchangeably, and also outer model and measurement model. So they actually represent same meaning. Inner model or a structural model refer to relationship between constructs. So when we have a framework including three antecedent and one endogenous variable, so the relationship between antecedent and endogenous variable is a structural model or inner model. If we have attitude, for example, subjective norm and perceived control that influence on intention to, for example, purchase a green product or book or stay in green hotel, right? So the relationship between these three variables called inner model or a structural model. But what's outer model or measurement model? Outer model or measurement model refer to each construct, the way that we measure each construct. So in other words, outer model or measurement model refer to relationship between items and construct, items and latent variable. So from here, refer to this structural model and outer model, we need a structural theory and measurement theory in our study, in literature review. So we need to support our inner model or structural model by a structural theory. For the example that just now I provided for assessment of for a relationship between attitude, subjective norm, and perceived control on intention to stay in green hotel. For example, we apply theory of planned behavior. Theory of planned behavior can be a structural theory. And this theory can support our hypothesis, a relationship between IVs and DV, endogenous variable, exogenous variable, and endogenous, right? So inner model or structural model that includes hypothesis, our hypothesis should be supported by structural theory. But also we need measurement theory. Measurement theory supports the way that we measure each construct. Measurement theory is actually the very, very important and critical, like structural theory. Our framework, our conceptual framework, and our hypothesis development is not acceptable without having a structural theory, and also is not acceptable if we don't have enough justification for measurement of each construct. Later, I will discuss the importance of this measurement and why we say measurement is very important. So we need to have measurement theory and structural theory. Okay, in this two figure, you can see inner model and the outer model. For example, here, okay, relationship between variables, relationship between construct. Okay, you can see relationship between construct. This relationship is a structural model. So this relationship should be supported by structural theory. But relationship between items of ease of use and this construct. So this one. And for this construct and also this construct, all variable and construct that we have, this refer to measurement model or outer model. And measurement model and outer model should be supported by measurement theory. Right? Okay. This is another example. You can see here we have a structural model and outer model or measurement model. But now for measurement model, we have a very critical discussion. For measurement model, actually for assessment of construct, we have two types of construct. mainly. But later we will see, actually we have 3 types, not 2 types. But now we can see in the literature, we have 2 main types of measurement theory, or 2 types of measurement model, or measurement of each construct or variable. These 2 main types are called the reflective and formative. Reflective has a very, very long tradition. From the beginning of 19, right? 19th century. But formative, recently, actually, in these 2 decades, the importance of formative and the nature of the formative nature of construct actually they came to attention of scholars in different social science disciplines, especially management and marketing, and later in tourism and hospitality. But what's the difference between formative and reflective? And what's the importance of understanding formative and reflective? Actually, this is definition of reflective construct and a mathematical equation and representation of reflective construct. In reflective construct, you can see the direction of arrow in reflective construct is from construct to items. And here you can see the statistical presentation or a statistical formula for reflective construct. Here you can see each indicator. For example, in first equation, x1 represents the meaning of construct plus error. And representation of meaning of construct is shown by lambda. We call lambda here is called loading or outer loading. You are familiar with the factor analysis, right? In first generation, when we want to categorize and abstract some items under some component or construct, we run factor analysis. And based on the loading of items on each component, we say, okay, this item belongs to this construct. This type of understanding, statistical understanding of relationship between item and component, item and construct is for reflective construct. So for reflective construct, lambda has a critical role, and lambda show relationship between item and construct. And actually lambda to the power of 2 presents explained variance of construct, explained variance of construct on item, on indicator. So how many % of variance of construct is explained by this indicator? So we say lambda should be higher than 0.7. So lambda to the power of 2 should be higher than 0.5 and 50%. So we say x1 or each item in reflective construct should represent at least, should explain at least 50% of variance of variable construct. For example, if you have three items to measure satisfaction, each item should represent 50% of meaning of satisfaction. So this is the way that we actually represent and explain reflective construct. Traditionally, most of research we consider our construct, our variable, as a reflective construct. But actually, it's not correct in all situations. We have another type of variable, another type of measurement model. It's called formative. In formative measurement model, the mathematical formula and the relationship between items and construct follow another approach, follow another, actually the mathematically another equation. Here you can see these three items together. You can see construct is W1 X1, W2 X2, W3 X3. So three items together establish construct. So when we want to measure satisfaction, it doesn't mean for formative, each item represents satisfaction. Three items together should represent satisfaction, should form satisfaction. So here you can see loading is not important here. Here we talk about weight. So these weights together and each item all together form or establish latent variable. So we need to actually differentiate, we need to distinguish at the beginning of our research that our measurement model and the type of each construct is reflective, follow reflective measurement model or formative measurement. But what's the definition of reflective and formative? Here is a very simple example to understand formative and reflective. Here we have satisfaction. Satisfaction of hotel guests. So we decide to measure satisfaction based on two different sets of items. In first study, we measure satisfaction based on these three items. I feel well in this hotel, so measure my satisfaction based on answering to these three questions. I feel well in this hotel. I'm always happy to stay in this hotel, and I recommend this hotel to others. So this is one set of items that I apply to measure satisfaction. But what's the nature of this item? If you look at this item, each item separately can represent the meaning of, whole meaning of satisfaction. And our expectation for the answer of the respondent to each question is high correlated answers, similar answer. For example, if first respondent answer strongly agree to first question, we expect this respondent answer to second question also strongly or strongly agree or agree. If we have a 5-point Likert scale from 1 to 5, and for first question answer 5, so for second we expect the respondent answer 4 or 5, because the answers are high correlated. If I feel well, so I'm happy to stay, and I recommend to my friend. If our items to measure satisfaction follow this direction, it means each item can represent the whole meaning of construct. Items are high correlated, right? Items are high correlated. If we remove one item, still other items can measure the meaning of satisfaction. If we have this type of items, it means the nature of items to measure satisfaction is reflective. But if we ask other type of questions, if we ask about service, about personnel, and about room equipment, so we ask the service is good, so respondent should answer to this one. The personnel are friendly and the room is well equipped. What's our expectation? The answer to first question can be strongly agreed. When we go to a hotel, the service is really good. Personnel are very friendly. But actually, we are not satisfied with room equipment. We are not satisfied with environment, but we are very satisfied with the behavior of personnel. So we have in this type of items, we measure satisfaction from different aspects, from different perspectives. And we don't have expectation that answer to question be high correlated. Answer to questions can be very different. If we have this type of questions, our construct, our measurement model is formative to measure satisfaction. So we need to understand the items that we apply to measure our construct. And we need to justify that these items are reflective items or formative items. Also, we have another type of, third type of items is composite. Composite, actually, the concept of composite construct emerged very recently by some scholars, and they discuss formative construct can be two different types: causal formative and composite formative. Actually, in composite construct or composite formative, we don't have error term here. What does it mean? It means we have all items to establish a construct. Actually, in formative construct, this error term refers to missing items. Here, for satisfaction, we include 3 items. So we measure satisfaction from 3 perspectives. Also, we can add more perspective. We can add environment, we can add accessibility of hotel, or we can add more aspect to measure satisfaction. But here we don't have. Only we measure based on these 3. So these other missing items that we didn't include to measure formative construct actually establish this error term. This is error. This is missing part of measuring satisfaction. But in composite construct, we don't have this missing part. Why? Because actually composite construct is based on Hensler. Hensler is one of the top scholar that actually brought up this concept and composite with his colleague. And they discuss and publish several papers related to this composite construct. Based on his definition, composite construct is an artifact. It's something that we create. Not something, not latent variable. Latent variable, we have 2 different types: formative and reflective. If items represent whole meaning, each item represent whole meaning of construct, so is reflective. If all items together establish construct, is formative. But we have another type, artifact. We design construct. For example, here, okay, our construct is frequency of watching TV. But we include 3 items to measure this constraint: watching TV during week, watching TV on Saturday and Sunday, because of difference between these 3 times and concept. So these 3 items, watching TV on weekdays, Saturday and Sunday, can represent, right, and can cover all times for watching TV, frequency of watching. So we can measure frequency of watching TV based on these 3 items. We don't have any error term. We design this construct based on these 3 items. This is another example. Marital status. So we can design based on these 3. We design. But actually, there are some discussion around this composite construct, and still is underdeveloped. The paper that I show you, editorial, that we published in 2018, we try to discuss and clarify in simple word the difference between formative, reflective, and composite. Actually, in this paper, we discussed that, okay, based on Hensler and some study, composite, we don't use the effect or cause and items to measure. Actually, composite construct, items are ingredient of construct. So we add these ingredients to establish this construct. And the most of time for composite construct, we don't have conceptual unity. But actually, in some study, when we are working with second order construct, for example, we measure perceived value. We want to measure perceived value. And for perceived value, we have 3 dimensions: functional value, social value, and emotional value. So these 3 dimensions measure perceived value. But these 3 dimensions formatively measure perceived value, because these 3 dimensions are 3 dimensions from different aspects to establish perceived value. But actually, these 3 dimensions, we are certain that these 3 dimensions establish the whole meaning of perceived value. So there is not any other dimension to be added. So this type of second order construct also can be composite. But we have conceptual unity for this type of second order construct. And we don't, these 3 dimensions are not only ingredient. There is something that exists in real world. But still, this concept is underdeveloped, and there are many debate and discussion around this concept for definition of, especially for definition of composite construct. But we need to understand for our research, right? Later, I will show you some criteria for assessment of composite and formative. And actually, we need to apply, why we need to understand, because we need to apply different criteria for assessment of reflective, formative, and composite construct, for assessment of measurement model, for assessment of reliability and validity of construct, right? Okay, so this is something related to formative, reflective, and composite construct. But as I mentioned at the beginning, a structural equation modeling can be categorized in 2 different groups: covariance space SEM and variance space SEM, or PLS-SEM. Covariance space SEM is developed in 1970. Okay, where is my? Still, you can see my presentation.
Yes, Dr. Mostafa, we can see the presentation.
Covariance space SEM is developed in 1970 by George Koch, right? And this scholar, when developed this technique under structural equation modeling, covariance-based structural equation modeling. Also, he developed a software to perform covariance-based SEM. Israel software to perform covariance-based SEM. So, because of availability of software, this method was very popular. And when we say SEM, most of people think about covariance-based SEM. But actually, covariance-based SEM and PLS-SEM was these two different methods. I'm not talking about software. These two methods were developed almost at the same time. In 1980, Hermann Wald was the supervisor of Carl Gyroscope. With Gyroscope, they identify some limitation for application of CB-SEM. So they develop PLS-SEM. And in 1980, PLS-SEM was available. But the software to perform PLS-SEM, first software, PLS Graph, was developed in 1990 by Wing Chin. So scholars and researchers actually started to apply this method much later than CB-SEM. So this method is CB-SEM is much more famous and well-known compared to PLS-SEM because of availability of software. But actually, these two methods, based on developer of this method, Hermann Wald and Carl Gyroscope, was actually these two methods are a complementary approach, complementary method, not competitive. Because the aim of these two methods, and the objective of studies to apply these two methods are totally different. So we need to understand when we have to apply PLS-SEM and when CB-SEM, covariance-based SEM. PLS-SEM is known as a composite-based SEM. This composite is different with composite construct. This composite refers to the method, the algorithm to perform this method, to run this method statistically. So partial least squares or PLS is called composite-based SEM. But CB-SEM is known factor-based or common factor-based SEM. The objective of, or the algorithm of the algorithm that is applied to perform CB-SEM is to maximize, to minimize the difference between covariance matrices from data and model for CB-SEM. But for PLS-SEM, the algorithm is to maximize explained variance of endogenous construct. So in CB-SEM, actually, the algorithm focuses on minimizing the discrepancy between covariance matrix from data and covariance matrix from model. So the algorithm tried to minimize this difference, discrepancy. So in covariance-based SEM, goodness of fit is very important because goodness of fit refers to this discrepancy. And goodness of fit are some criteria that we measure, we assess this discrepancy. But PLS-SEM actually focus on maximizing explained variance of DV, endogenous construct. So we don't have anything for comparing covariance matrix from data and covariance matrix from model. So you can see the objective of these two methods, the algorithm of these two methods are different. So they have to apply for a study with different objectives. So CB-SEM is suitable for study that focus on theory testing. Why? Because when we compare covariant matrix from data and covariant matrix from model, when we compare these two, it means we want to set and establish theory in a new context and see the covariance matrix in new context and based on new data, how much is different with covariance matrix from data, right? So from covariant matrix from model and data, how much difference, how much discrepancy there is between these two covariance matrix. So the aim of our study should be theory testing to apply CB-SEM. But what about PLS? PLS-SEM, the objective is maximizing variance, explained variance of DV by IV. So it's suitable for theory development. When we develop a new theory, new model, we have to check how this model, how much of variance of DV is explained by these IVs that we include from different theories, different models. So we try to maximize this variance, this explained variance. So PLS-SEM is suitable for theory development and also for prediction. So if the objective of our study is prediction or theory development, we have to use PLS-SEM or variance-based SEM. But if the objective of our study is theory testing, we have to use CB-SEM or covariance-based SEM. So this is the criteria that based on this criteria, we can identify when we should apply PLS-SEM or CB-SEM. From this point, we can identify some criteria for application of PLS-SEM and CB-SEM under umbrella of SEM, structural equation modeling. First is the main reason, main justification. The objective of our research should be theory development and prediction, or prediction for application of PLS-SEM. But if the objective is theory testing, CB-SEM is preferred. If prediction is the aim of our study, PLS-SEM is preferred. But we go also to another criteria. PLS-SEM can work with the complex models, but CB-SEM, if our model is very complex, CB-SEM is not able to handle complex model. So if our framework, our model is complex, so PLS-SEM is preferred, especially if we have combination of formative and reflective construct. Some of our construct is formative and some of our construct is reflective. So PLS-SEM is preferred approach, and the CB-SEM cannot handle this type of situation. Right? So this is two main criteria to justify application of PLS-SEM over CB-SEM. Right? Also, there are some other criteria that this is a common mistake that researchers to justify application of PLS-SEM directly go to these criteria, but these criteria are not main criteria. For example, PLS can work with smaller sample compared to CB-SEM. And we can get higher power in by applying PLS-SEM compared to CB-SEM with smaller sample. But it's not main reason. Also, PLS-SEM, because the PLS use bootstrapping and resampling method, can deal with non-normal data, can apply non-normal data. But CB-SEM, if we want to apply CB-SEM, we have to add some technique. We need to run bootstrapping for non-normal data. Still is possible, but PLS-SEM is preferred. But after two main reason and two main justification. Without these two main justification, it's difficult to justify application of PLS-SEM. Okay, but these can be another criteria, smaller sample or non-normal data for justification of application of PLS-SEM. So this is answer to when we apply PLS-SEM compared to CB-SEM, right? Here in this table, in the literature, actually, there are some differences between, or some criteria to apply PLS compared to CB-SEM. Also, there are some software. This is another common mistake. Don't mix up software with technique. CB-SEM, covariance-based SEM, is a technique, it's a statistical technique, advanced quantitative analysis technique or approach. But this software, MOS, Lisrael, M+, EQS, are only software. So you can run CB-SEM by these software, right? So MOS is not technique. MOS only is software. So you can run CB-SEM by MOS. You can run CB-SEM by Lisrael or M+ or EQS or other software. Recently, we have our programming package include many of different packages that we can use for different analysis techniques, including CB-SEM and PLS, right? And here there are some software again to perform PLS-SEM. Smart PLS is very common software. VARP PLS is another software. Adonco and some other software, you can see there are many to perform PLS-SEM, right? So don't confuse between method and software. So now, so far, I discussed why and when. And now I want to briefly explain how. Okay, if we decide to use the PLS and we have enough justification for application of PLS, how we can assess our model using PLS. I try to briefly go through assessment of measurement model and structural model, and then we will have time for your question, if any question. Okay, for assessment of measurement model and structural model, actually, I show you this paper. This is our paper published in 2018. And here we provided a very clear and simple guideline to follow for different steps of assessment of measurement model and structural model. So this can be a very good guideline and paper to follow for reporting, for assessment of model and reporting the result. This is another very good paper that published in 2019 by Professor Hare and his colleague. And actually, one of the main book for application of PLS is Hare book, published in 2013 and second edition 2017. And there are many papers, but this is one of the recent paper published by Professor Hare and his colleague, 2019. And in this paper, they explain when to use and how to report the result of PLS-SEM. So this also can be another good paper to follow for assessment and reporting the result of PLS. Okay, but how actually we need to report, we need to assess and report the result of PLS. Actually, when we decide to apply PLS, we need to assess our framework and our model in two different steps. In first step, we need to assess measurement model. And then after assessment of measurement model and fulfill the criteria for assessment of measurement model, we can go to assess a structural model. In assessment of measurement model, based on nature of our construct, formative, reflective, or composite, we have to apply different criteria for assessment of measurement model. So we need to understand what's the nature of our construct. Is it formative, reflective, or composite? Because we need to apply different criteria if it's formative or reflective or composite. So the first step is assessment of measurement model, and the second step is assessment of a structural model. For assessment of measurement model, for reflective construct, we need to check reliability and validity. We have different criteria for assessment of reliability and validity in when we apply PLS. For assessment of reliability, first we need to check the loading. You remember when I show you the mathematical formula for reflective construct? One of the most important criteria is loading. So in first place, we need to assess loading. And the loading should be higher than, if you go through the literature and the guideline that I mentioned, you can see threshold for each criteria, criteria. But now I just briefly introduce these criteria. First is to check reliability and to check indicator reliability and loading should be higher than 0.7. But actually between 0.5 and 0.7 still is acceptable if we we fulfill other criteria and establish reliability and convergent validity. Other criteria like composite reliability, like ROA, like Kernbach alpha, and AVE. So in first place, we need to check loading and should be higher than 0.7, but loading lower than 0.5 should be deleted. The item with loading lower than 0.5 can be deleted. But the second step is internal consistency or construct reliability. We need to check composite reliability, Kernbach alpha, and ROA. And these criteria, actually, if you use different software provide these criteria for calculate these criteria. And the value of these criteria, all these criteria should be higher than 0.7. If some of these criteria are not higher than 0.7, it means you need to look at loading and see the item with low loading should be deleted to increase the value of internal consistency, the value of these criteria. So composite reliability. So this is key criteria for assessment of construct reliability. Another criterion for assessment of reflective construct is average variance extracted. So we need to assess convergent validity after established reliability indicator and construct reliability. Assess convergent validity, and convergent validity can be assessed based on AVE. And it should be higher than 0.5, means 50% of variance of average of construct are explained by item. I think some of the audience are not
The audience, please keep your microphones mute. Kindly microphones.
And discriminant validity is another criteria for assessment of validity of reflective construct. But discriminant validity with reliability and convergent validity. Reliability and convergent validity refer to divergence between convergency between items of each construct. But discriminant validity, actually, based on different criteria, we assess divergence between different constructs. So it means different constructs involved in our framework should not be similar, should not represent same attribute. So how we check this discriminant validity? There are some criteria, and suggest these criteria like Fornell Larker criteria and cross-loading. And this criteria was developed hetero-trait monotrait ratio, HTMT ratio. And actually, literature suggests to apply these criterion and HTMT together for assessment of reflective construct. Another one is the full collinearity, but still is under, and especially for formative construct. At the moment, for formative construct, we don't have any criterion to assess discriminant validity. Full collinearity can be a criterion for assessment of discriminant validity of formative construct, or when both formative and reflective construct. Okay, this is I already explained discriminant validity, and okay, this is for reflective construct. For formative construct, actually, we have different criteria, but before applying different criteria, applying criteria for assessment of formative measurement model, we need to check external validity or redundancy analysis for formative construct. What does it mean? It means that for formative, remember when I explained formative construct, we have an error term on construct level. And this error term in construct level represent missing item for formative construct. So if this missing item, actually the big part of this formative construct, it means this available item to measure formative construct only can measure small portion of this construct. For example, satisfaction, we have only 3, and we see these 3 satisfaction, these 3 construct, these 3 as item, and these 3 aspects only can measure 30% of meaning of satisfaction. So it means the missing value and error terms. To avoid this one, when we have a formative construct, also we need to include some reflective item to measure this construct, or recent literature recommend to add one overall item. For example, if this one is satisfaction, in the questionnaire, when we design our questionnaire, we add one overall item to measure satisfaction, but don't need to include this overall item to our framework. Only we need to check relationship between this formative and this overall item. And the relationship between this formative construct and overall item should be higher than 0.7. It means these formative items at least establish 50% of meaning of formative construct. So we need to include this overall item in our questionnaire. If we don't include after data collection, we cannot do anything, right? So from the beginning, you have to identify the nature of your construct. And if it's formative, you need this overall item to measure, to assess external validity or redundancy analysis. Like this one, satisfaction. Here, the relationship should be higher than 0.7. And it means 50% of meaning of satisfaction is explained by these three items. Another criteria for assessment of formative construct, first one is, and very important, is VIF, or full collinearity, multicollinearity VIF. And multicollinearity VIF between items of formative construct should be lower than 5. If it's higher than 5, it means the similarity of items is high. And we need to reconsider this formative construct. When we pass this criterion, we can go for second one. Second one is assessment of weight. Here we don't have loading, weight. And the weight should be significant, only significant. We don't have any threshold for weight of formative construct. We don't say higher than 0.5, 0.7, or lower than. Only the weight should be significant to be acceptable. So we have two main criteria for formative. But if the weight is not significant, actually now we can check significance of loading. And if the loading is significant, we can keep item of formative. Here you can see composite measurement model, and composite measurement model, actually we need to add one more criteria, is nomonological validity. We need to check nomonological validity also for composite construct. Okay, now, okay, just very quick review assessment of a structural model. For assessment of a structural model, we need to check R square, because R square, actually, if you're familiar with the first generation, R square represents the explained variance of IV on DV. So we need to report and we need to check R square. We need to check significance of path coefficient, effect size, and the predictive validity or predictive relevance, because PLS is prediction-oriented method. But previous literature actually suggested Q square for assessment of predictive validity. But recent literature suggested PLS predict out of sample prediction. And this out of sample prediction is more accurate and precise to assess predictive validity of model. But assessment of predictive validity is important if our objective is prediction. There are different thresholds for R square, but actually R square
Hello everyone. I think Dr. Mostafa has dropped from the live broadcasting. So give us a little moment to get him on board once again on this. And apologies for the inconvenience.